Hi there, this is your moderator, Lori Dearman with WebAttract, and you are in the right place for how light curable materials increase process efficiencies and improve PCB performance, sponsored by Dymax Corporation. Now, for those of you who haven't heard of Dymax, they're based in Torrington, Connecticut, with global locations in Asia and Europe, and are manufacturers of UV light curable adhesives, coatings, oligomers, and compatible UV light curing and dispensing systems. In just a moment, I'll be introducing our panel of thought leaders, as today's webinar is about hearing from these experts as they discuss real-life examples of how light curable conformal coatings and board-level maskants can cost-effectively increase productivity. Now, today we have a diverse audience of professionals representing a variety of industries, all here to learn techniques and to see specific examples of how others have been able to significantly cut processing time, increase throughput, and dramatically lower manufacturing costs while using greener processes. Now, regardless of your industry segment or your location today, we are confident that you'll find today's webinar of value. We would like to kick things off today with a quick interactive poll. So folks, coming up on your screen is that first poll. We'd like to hear from all of you. What type of conformal coatings are you currently using? And in this case, you're welcome to select all that apply. Is it light curable, silicons, paralenes, acrylics, or perhaps you don't use any? All right, looks like 42% weighing in with light curable, 44% silicons, 25% paralenes, 53% acrylics, and 14% not currently using any. So certainly appreciate your weighing in on that. I know that this information will be very helpful to our presenters as they work through their presentations today. So thanks again for participating. Now, before we do get started, allow me first to give a brief introduction of our featured speakers for today. We have Chris Morrissey and Virginia Hogan, who will be presenting on the various technologies, while Richie will be coming in to share with us some case studies on how these technologies are being used on the ground. So Chris will be getting us started. So first, a few words in the way of an introduction for Chris. Now, Chris Morrissey is the Global Product Manager for Coatings at Dymax Corporation, focused on the global electronics industry with emphasis on printed circuit board coating technology used in markets such as automotive, appliance, consumer electronics, aerospace, industrial, and others. Chris has extensive experience in both materials and electronics and has worked directly with many of the global leaders across these markets. He's responsible for Dymax's current product portfolio, as well as for leading the company's new product direction for electronic coatings. So, Chris, pleasure to have you here today. Welcome to the webinar. How are you?
Hi, Lori. I'm fine. Thank you.
All right, and folks, Chris is going to give us an overview and discuss the many benefits of light-cured conformal coatings. So over to you, Chris.
Thanks again, Lori, and thanks to all the webinar attendees. No matter what size your company is, these are some of the most challenging economic conditions we've faced in a long time. That being the case, manufacturers are looking for ways to improve productivity while reducing costs and continuing to improve product performance. And all of this while not sacrificing product quality, of course.
Now, absolutely, we're all looking very carefully at the bottom line. So just how do these initiatives translate to the bottom line?
Well, they actually translate quite well. Manufacturing efficiency improvement first starts with an objective that's typically converted into a process improvement. The improvement is for the most part driven by things like cost, time, volume, design changes and the like, or it can be driven by market needs or even internal company needs. Addressing the complete manufacturing process can yield significant improvements from established norms. A key part of the print circuit board manufacturing process is the surface coating or the conformal coating on the print circuit board and how it can improve performance and productivity. At the same time, taking advantage of other process improvements such as masking that we'll also talk about shortly. Ultimately, the print circuit board will be key contributor to critical performance in automotive, electrical components, instrumentation, appliances, consumer electronics, and other applications. Some of the products, such as Maskants, they're temporary, and some, like conformal coatings that we'll be talking about, will stay on the printed circuit board and be part of the performance enhancement.
Now, Chris, before we jump right in and start the discussion on UV light curable conformal coatings, perhaps we can take a step back and look at how UV technology works in general.
Sure, absolutely, Laurie, thanks. And here, the typical UV curing process focuses on the 315 to 405 nanometer light spectrum. At times, even the visible light spectrum. Proper light curable material compatibility at wavelength, along with the proper curing intensity, are essential components of the curing process. And this is an important fact, actually. Here's a slide showing a sectioned pyramid. UV light curable materials are typically made up of the basic components that pretty much stack up as you see on the slide. First is the oligomer on the bottom, which gives the basic properties such as chemical resistance or heat resistance. The monomer is used to add specific properties, things like elongation, flexibility, increased adhesion, lower shrinkage, that type of thing. The additive is the fine-tuning, for color, fluorescence, or surface tackiness. And then the photoinitiator package you see on the top in blue there enables the material to cure. All of these become the formulation for the light curable material. That said, as I noted earlier, you need the proper energy to initiate the curing process. This slide shows the absorption curve for photoinitiators. The photoinitiator package is designed around the spectral output of the curing equipment, which varies. This slide, you see the peak at around 385 nanometer wavelength, aligning with the photoinitiator package of the material. As we talked about in the pyramid, formulations are designed with a specific type of curing mechanism in mind. For example, a broad spectrum curing unit has a spectral output from 315 to just over 400 nanometers into the visible range. The photoinitiator package will be optimized to match the same range. In comparison, for LED curing, the wavelength is very narrow or specific, like 385 nanometers. So optimizing a formulation for LED curing means that the photoinitiator package needs to match the same wavelength in order to initiate and complete the curing process. So here's an illustration to show what actually is happening. Each quadrant is labeled 1 through 4, as you can see. In box 1, the light curable material is in an unreacted state. In box 2, the curing process is beginning. This is when the photoinitiator in the material is exposed to the energy source of the proper spectral output. It excites and fragments photoinitiators and results in generation of free radicals. In box 3, in the lower left, the free radicals actually begin to attach themselves to the acrylates that make up the light curable material. This results in polymeric chain radicals. The process is repeated until all the radicals are attached, and there's polymer termination, which is basically cured material, and that's what you see in box 4.
Now, in terms of benefits, can you share with us some of the benefits of light cure technology?
Yes, Laurie, I will, and because the incorporation of light curable materials can really provide significant benefits over conventional solvated materials. Barry Richie actually is going to share a few customer experiences with everyone in a few minutes. Light curable materials offer advantages over other technologies in a few specific ways, and these can include lower operating costs. And this is from low labor needs and low energy demand, and this is combined with high throughput. They offer 100% solids materials or solvent-free products, and they can also increase production capacity due to fast cure times and small production footprint.
So now that we know how light cure technology works and have an idea of some of the advantages it can deliver, why don't we talk more specifically about UV light curable conformal coatings and how they can help deliver improved performance and productivity.
Okay, Laurie, I'd be happy to. And with regard to conformal coatings, they're available in a variety of solvent-based as well as 100% solids forms. Key advantage to UV light curable conformal coatings in Maskants is the ability to use a green or 100% solids material. UV curable urethane acrylates circled on this slide are a perfect example of this. Just as a quick note, which is probably very obvious to most of us, but conformal coatings are thin, protective polymeric coatings, most often used to provide environmental protection without adding excessive cost or weight. Typically, they're applied at 50 to 225 microns thick, and they conform to the board, allowing for the protection and coverage, ultimately extending the life of the printed circuit board. They can be applied in a variety of ways, including dipping, brushing, spraying, float coating, etc. Yet the most common application method for light curing materials is spraying. The coating can be applied over the complete board or more efficiently in a selective conformal coating process, that is, putting the coating only where you need it. Let's talk briefly about shadow areas and what is a shadow area. A shadow area is the area beneath components where a conformal coating may flow, and relative to light curing, it may not be exposed to the curing light from above. So if this is the case, it's important to have a secondary curing mechanism. This is often heat or a secondary moisture cure, which is really gaining in popularity because it can cure in these shadow areas using just available ambient moisture. Both secondary heat and secondary moisture cure can eliminate concerns about uncured material on the printed circuit board. Once the coating is applied, typically by spray dispensing, as we noted earlier, curing depends on the shape and complexity of the board as well as the thickness of the conformal coating. UV cure typically happens very fast and happens in seconds. This is unlike solvated chemistries, which take time to flash off solvents. The secondary cure depends on the cure type. However, with the tack-free UV cure, the secondary curing can happen while the boards are undergoing further processing. So, in particular, comparing UV light curable materials with a secondary moisture cure to other chemistries, there are a lot of advantages that can lead to increasing process efficiencies. The actual advantages do depend on the particular material offered by each of the coating manufacturers, yet currently commercial materials can offer things like immediate tack-free curing in seconds, fast curing under ambient conditions, and this can happen in as little as 2 or 3 days, reworkability, and this is a particular value for expensive printed circuit boards, and the lack of board or component damage from excessive heat or temperature processing, and this tends to be a big one. It's also common for light curable materials to fluoresce a bright red or blue to help with board inspection. With respect to performance, light curable conformal coatings are also robust enough to meet very demanding application requirements and also meet existing conformal coating performance standards. You probably at least most of the audience is somewhat familiar with those listed here. And finally, when it comes to performance and testing, there are a series of other common tests against which light curable materials have performed well, particularly compared to competing technologies. Tests such as flexibility, thermal shock and thermal cycling, temperature and humidity testing, as well as corrosion testing using salt spray or salt fog, as some reference it, and sublimated sulfur. These are at least some of the common requirements you'll see. So, so now back to you, Laurie.
Well, thank you so much, Chris. Really appreciate it. And don't go too far because we'll have you at the tail end for the live Q&A. And now that we know how the technology works and some of the advantages that it can deliver, Richie is going to share with us some specific examples of how UV light curable technology and conformal coatings help deliver improved performance and productivity to a global manufacturer. But before I pass the mic over, a few words to introduce Barry. Barry graduated from the U.S. Army Academy of Health Sciences Brooke Army Medical Center in San Antonio, Texas during the Vietnam era as a clinical specialist in a MASH unit as a dust-off medic and saved many lives. After honorary discharge from the U.S. Army, he worked as a physician's assistant until switching gears when he was recruited by Union Carbide to perform tissue compatibility studies for implantation devices for Parylene conformal coatings, as well as coating space electronics with work on Space Lab and the International Space Station. He is considered one of the foremost global experts on all type of conformal coatings and electronics protection in general, and has authored several white papers and presentations on conformal coatings. His employment career also includes General Dynamics, Loctite Henkel, and Dow Corning, in which he retired in 2015. Soon after retirement, he formed his consulting company, Electronics Protection Chemistries Group, and serves as Senior VP and CTO. His company has consulted for Google, Apple, Samsung, Dymax, Blue Star Silicons, Alpha Sites, and many formerly competitive material suppliers. So Barry, it is a pleasure and an honor to have you with us today. How are you?
Lori, I'm doing very fine. Thank you for that tremendous introduction. It could almost double as my obituary when the time comes.
And over to you, Barry.
Lori, this application case story that I'm going to discuss, I want to give you a little background on. This case involves a large power inverter manufacturer. As you know, an inverter is an electronic device or circuitry that changes direct current, DC, to alternating current, AC. Their printed circuit board processing line included loaders, coaters, heating ovens, and unloaders for processing the current product volumes. The manufacturing setup included both full processing lines as well as manual lines that were dedicated to specific product line production. Long, large heating ovens were used to vaporize and vent the solvent generated from the current conformal coating in the full line process in order to develop a tack-free surface on a PCB, which was then further processed down the production line. Ultimately, performance demands and a 1/3 increase in production had to be achieved.
So can we take a look at the traditional processes that they were using and perhaps share any issues that they were up against?
Absolutely, Lori. To meet current production rate demands, their system would need to be tuned with a 25 micron maximum dry coating thickness based on the solvent-based coating and process, yet at this thickness they could not meet the existing electrical requirements of their global customers. Air pollution and odor due to solvent evaporation was a serious problem in these factories as well, even after extensive ventilation system upgrades were performed. This was evident on the production line as well with work in process and inventory and storage. Add to these issues the requirement to increase production efficiencies to meet planned demand increases, yet in the same floor space at a comparable or lower cost.
So it sounds like they had some significant challenges they're up against, so could you share with us how they solved their dilemma?
Certainly, Lori. They did it by the integration of a light curable material chemistry and process. First, they selected 2 different UV curable materials that met their customer specifications and also had a secondary moisture curing component. The materials were tack-free after UV curing and fluoresced a bright blue to improve process inspection. They then optimized their conveyors, their curing lamp positioning and curing area, made adjustments to optimize the impact of ventilation in addition to the lessened problems due to their move away from solvents. And they adapted their manual lines with similar light curing material line configurations to which quickly handle product through the process of a broad-based product mix.
And so let's take a look at some of the results that they experienced.
Well, as a result of these improvements, both in product chemistry and product process efficiency, their performance objectives were met. They provided PCBs to the critical performance standards of their inverters. They reduced the odors, which improved worker satisfaction and safety. They increased output within the same physical footprint and ultimately met the cost targets necessary to meet the market demand and profitability requirements of their organization. All around, a successful implementation using the benefits of most optimized solution measured against their goals. Lori, back to you.
All right. Thank you, Barry, for that case story. And I know you've got another one at the second half, so we'll see you back shortly. And at this point, I'm going to be passing the mic over to Virginia Hogan. First, some words in the way of an introduction. Virginia Hogan is Global Product Manager for Dymax Corporation, which includes support of the aerospace, automotive, energy, consumer electronics devices, and orthopedic implant industries. Virginia has over 13 years of experience with UV curable adhesives and 20 years of experience in the aerospace industry. Her efforts are focused on product line development to meet market and customers' needs with the next generation masking and gasketing products. Ginny, pleasure to have you here with us today. How are you?
I'm very fine, Lori. Thank you.
All right, folks, Ginny will be discussing light curing maskants, but before we get to that, we have for you one more interactive poll. So folks, coming up on your screen, you should see a poll, and we'd like to hear from you. What type of mask are you currently using on your PCB? And is it tape, caps, latex-based, light curable, or perhaps other? Okay, it looks like 59% of our audience saying tape, 32% caps, 41% latex-based, 44% light curable, and 3% saying other. Ginny, any thoughts on these responses?
Well, I'm pleased to see the diverse use of maskants, and it gives us a great basis to start with to talk about the benefits of light curable maskants. So Lori, thanks for sharing those results.
Absolutely, and over to you, Ginny.
Thank you, Lori. And good afternoon to all that have joined us today. As Chris mentioned earlier, when the printed circuit board is designed, there are areas designated to be free of coatings, which could include pin connectors, through holes, and zones on the board itself. Maskants are used to protect these, keep out areas during the conformal coating process. Just as we learned there are different types of conformal coatings, there are different masking options for the protection of the connectors and the board keep-out zones. First, let's talk about tapes. As we saw in the results, many of you are currently using tapes. Tapes and dots are a very common method, which do not require a curing step, but they are very labor-intensive application, especially on highly populated boards where there's very little space between the connector to be able to achieve a good seal against the board. Tapes are also bringing some challenges of removing the residue left after the coating has been applied and heat cured. This could be the root cause in not passing the SIR testing on the boards. Caps are another common masking option. There are standard caps available which may or may not fit your connectors. Custom caps may be required to accommodate the exact height and shape of your connectors. Caps are not effective for through holes or on the board level areas. Caps have a limited use as they lose shape and sealing after multiple uses, causing rework of the conformal coating. Latex-based maskants are yet another option for protecting your connectors and the board surfaces. Latex-based maskants are 50% solids, so you'll need to flash off the solvent or heat cure the water or air dry the maskant. The curing times range from 15 minutes for heat up to 8 hours if you're air drying the maskant. Depending on the viscosity of the maskant, multiple applications and multiple cure cycles are required to achieve the full protection coverage. Some of the latex-based maskants have an ammonia content, and that may cause discoloration or corrosion of the pins. Now I'd like to introduce you to the light curable maskants for the printed circuit board connection protection. How do light-curable maskants help improve the productivity of your conformal coating process? Before I can answer that question, let me introduce you to the light-curable maskants. I want to share with you some of the key differences of light-curable maskants to conventional masking options that we just explored. First, the maskants conform to the simple configurations such as a through hole or complex connectors with formulations that are not slumping and will not migrate off of the connectors onto the board. These formulations are compatible with copper and gold pins, eliminating the concern of corrosion or discoloration. Application of the maskants can be done by manual dispense process, or for more precision applications, you could select to use an automated process such as jetting, or a multi-axis valve system could also be used. These formulations are developed to be a manufacturing aid with either UV conformal coatings or solvated conformal coatings. Unlike the latex-based maskants, light-curable maskants cure on demand in seconds rather than hours, which means the boards are readily available for your conformal coating process. There is no need to rack your boards to wait for the maskant to cure. The light-curable resins are applied to the necessary thickness with one layer of coverage with one cure cycle. Additionally, these resins are formulated with fluorescing agents for inline placement inspection, just as Chris had mentioned about the conformal coatings. When properly cured, the resins can easily be removed in one piece after the conformal coatings are tack-free.
So, Ginny, what are some of the benefits for the manufacturers?
Lori, some of the benefits are just a result of the characteristics that we just talked about with the on-demand cure, with being 100% solids. These all contribute to the total operating cost of the masking application, combined with the reduction in scrap and rework because of the reliability of these maskants. Light-curable maskants resins are 100% solids and solvent-free, reducing the environmental impact. Many available latex-based maskants are solvated or have an ammonia base that is harmful to the environment. Light-curable maskants are a greener option. The time required to process light-curable maskants is significantly shorter than solvated or heat-cure masking resins. Time savings allow for increased throughput, reduced lead time to your customer. The zero keep-out violations prevent rework of the conformal coating and contribute to the increased throughput. Light curing equipment has a smaller footprint than production heat curing ovens, which free up floor space. The shorter cure cycles and having boards immediately available for your conformal coating process increases your productivity. These resins are tack-free upon cure. The application of the one-part light-curable maskants can be done in either manual dispensing or, for more precision applications, as I've mentioned before, automated systems like jetting or a multi-axis valve system could be used. The light-curable maskants are formulated to be compatible with the gold and copper pins with no discoloration or concern for corrosion. So far we've talked about the techniques to enable faster processing, improve throughput with on-demand cure, greener processes with solvent-free resins. Now we'll take a look at a customer experience where they were able to lower manufacturing costs, reduce waste in their manufacturing process. Back to you, Lori.
All right, thanks so much, Ginny, and we'll have you back in just a few for the wrap-up and the Q&A.
Thanks.
Yeah, so let's go ahead and pass the mic back over to Barry for another case story. So,
Thank you, Ginny. As Ginny alluded to, the masking and demasking operations involved with conformal coating are probably the most aggravating and time-consuming bottleneck in the entire process. I would like to go ahead and review light curing masking solutions for increasing process efficiencies using the actual case story for an example. Thanks, Lori. A large global industrial electronics company whose designs and manufactures PCB assemblies for network communications, industrial, aerospace, and medical customers. This electronics company was faced with increased production demands and raising costs from rework. They sought out an alternative to their current latex-based masking process. It was their objective to develop an effective and efficient masking process for incorporation at their multiple assembly locations. This solution was to support an anticipated demand increase of 30%. Additionally, this solution had to improve product quality, improve process efficiencies, and increase output compared to their current masking processes. The selection of a light-curable peelable masking as a replacement to the latex masking, their needs were for a fast curing, reliable, and easily applied process. Throughput maximized with a time pressure dispenser, and apply the material in a multiple lamp conveyor, increasing the throughput of PCB during the curing cycle. This solution allowed the PCBs to be immediately available for the conformal coating process. As I mentioned earlier, this challenge presented by the customer was to replace the current latex-based masking with a faster curing, more reliable, and easily to apply and remove masking that was compatible with the connector pins. This masking had to provide the required protection, and also PCB had to pass the current SIR testing after removal of the masking while being compatible with the solventated conformal coating. Added to these issues, the requirement to increase production efficiencies to meet planned 30% demand increases, coupled with working with the same floor space and do so at a comparable or lower cost.
So, Barry, how did this company solve their dilemma?
Well, Lori, by using a light, curable, and peelable temporary masking, a throughput maximized with the time pressure dispenser to apply the material in a multiple lamp conveyor, increasing the ability of throughput during the curing cycle. This solution allowed the PCBs to be immediately available for the conformal coating process. Now let's look at the results of this solution. This customer had been using a latex-based masking to protect the connectors and adjacent areas on the printed circuit board. This masking had a drying time of 8 hours, whether it was 1 or 100 boards. Labor savings were a direct result of on-demand cure and achievement of zero keep-out area violations. The reliability of this masking reduced keep-out violations to zero, elimination of the conformal coating rework process. The rework was reduced from 40% to zero. This solution helped this company meet 30% productivity demand increase while also reducing their overall operating costs. This is a great example of how light curable maskings can and will provide advantages over traditional masking options. Back to you, Lori.
All right. Thanks so much, Barry. And we're going to be passing over to Ginny for a quick wrap-up before we get to our live Q&A. Ginny?
Thanks, Lori. To all the attendees, whether you're a Fortune 500 company, a small startup, or somewhere in between, you're all striving to achieve the increase in profit levels. As we talked about with Chris with the conformal coatings and with the light curable materials for masking, these products provide solvent-free, a greener solution, inline inspection through fluorescing, increased throughput with on-demand cure, reduced floor space with going with the light curable conveyors instead of heat curing ovens, and the on-demand. All of these contribute to the process savings and the reduced costs, increasing your profits. So it's through these characteristics of the materials that we are able to achieve the increased profits. Back to you, Laura.
All right. Thank you so much, Ginny. And folks, before we jump on those questions coming in, some information, how you can get more information or get started. We certainly invite you to review the webinar we are recording today, and you will receive a link in a follow-up email. You can research more about light curable conformal coatings and maskants on the Dymax website, dymax.com. It's also a contact option on the website with live chat and a contact us form. or we invite you to have a conversation with a Dymax application engineer to discuss your specific application. At this time, I would like to ask each of our panel members to step back to the virtual podium, if you will, and we're going to start with the questions that are in the queue. Got a number of them, but if you haven't input your question, feel free to go ahead and do so now, and we'll address as many as we can. First question here, I'm going to go to Ginny. So Ginny, question is, can I cure the UV curable maskant with a black light?
Lori, thanks for the question. Can you go back up to slide 12, where Chris was talking about the spectral output? The spectral output that we look at is from 315 to just over 400 at the visible light. This is the optimum cure range. A black light does not fall within that range, so consequently the black light is not going to give you the proper intensity at the right wavelength that we need to be able to cure these light curable materials, whether it's the masking or the conformal coating.
All right. Well, thank you so much for that. Let me forward our deck back to the end, and we'll get to our second question. Over to you, Chris. And that question is, you mentioned that UV curable conformal coatings are typically applied as thin coatings. Can you coat thicker, for example, 0.010 inches, I believe that is, or more in a single pass?
Thanks, Lori. Yes, you actually can. It depends on the board configuration. It depends on the conformal coat itself. But the key here is applying the material and still meeting the requirements you have. So very thin conformal coatings, especially in light curables that are typically spray coated, it becomes more difficult for the coating to build up. But there are materials. I know at Dymax we have a 9482 material, which is basically designed to coat thicker, but you also, in coating thicker, would be able to maintain things like UL flammability. So you have to think about the performance requirements that you have in addition to the thickness that you're looking to apply the conformal coat. But the fundamental answer is yes, it can be done. You just have to select the correct material.
Okay, gonna go over to Barry. Question is, what is the maximum thickness recommended to ensure proper UV curing and eliminate outgassing under parylene? Parylene.
Well, parylene is a gas deposited vapor that is done in a batch process under vacuum. Typically, parylene have a very high dielectric strength. In most circuit board applications, you're basically going to use 0.7 to 1 mil thickness, much thinner than the organic materials. It's also much difficult to see, and it can be very difficult to rework because there are very few, if any, solvents that will be able to dissolve it. So the only way to get it off is typically with a microblasting technique of some type. But parylene is designed to be applied very, very thin, and it's applied as a gas. The masking for parylene is very difficult. The connectors must be airtightly sealed, or that molecule will squeeze its way in there, and when you go in to put the board into the test rig, you're going to have a failure which would cost more rework.
Okay. This one going over to Ginny. The question is, I latex dip parts around 12 inches in length. Could the speed mask process replace this?
Lori, great question. One of the unique things about the speed mask process is it can be applied to any configuration, regardless of whether it's only 2 inches by 4 inches or it's as long as a dining room table. We have dispensing systems and curing systems that can accommodate the size of the part from the very, very small to the very large. So the answer is absolutely yes.
All right. Going over to Chris. You mentioned 2 to 7 days is the typical cure time for secondary moisture cure. Is it possible to hit a target of 3 to 4 days if the application demands it?
The answer, Laurie, is yes, you can. And then again, it depends. There are a number of different materials available. There are secondary moisture cure materials available that we can cure in 2 to 3 days is typical. Cures can be accelerated. So the answer is that yeah, it is possible to shorten that time frame. We do have materials that do go that range, and you just have to pick the appropriate material to do that, and then you have to apply it on a board that does see the correct amount of ambient moisture. But some of the systems that are available do take longer to cure, so you just have to select the correct material. But it's definitely possible to hit a target of somewhere in the 2 to 3 day range at ambient.
Okay, over to Barry. Is there any way to reduce or eliminate entirely delamination/flashing when removing UV curable maskants or tapes, etc.?
Absolutely. These types of masking materials being UV cured, it's almost impossible for them to delaminate unless we're applying them on a very dirty surface. And in which case the surface is dirty. As soon as the material is cured, you'll see evidence of delamination, but it seldom happens with these materials if the boards are clean.
Barry, one other thing that is a good thing to tell our audience about is that we would want them to remove the light curable masking as soon as the conformal coating is tack-free. Waiting until after it has moisture cured will make it more difficult. So the recommendation is to remove the mask as soon as the conformal coating is tack-free, just as an added tip.
All right,
Thank
fantastic.
you, Jenny.
Yeah. So Jenny, another question here for you. How did you determine the compatibility between the light cure masking and the solvent in the coating?
Great question, Laura. This is actually determined when we formulate these materials. We'll formulate to be for the oligomer. When we look back to the pyramid that Chris talked about of the components of the light curable material, the oligomer, which gives us a lot of the chemical resistance and the heat resistance, that is the key to the compatibility of the solvated conformal coatings. So when a light curable material is designed to be resistant to the solvents, we design that in right from the beginning to be able to be resistant to the various solvents. So that's how we determine. When you look at the product data sheet will say that it is solvent resistant. So that would be one of the key terms that you would look for on the product data sheet, that light curable masking is in fact resistant and compatible with solvated conformal coatings.
All right, Chris, I have a question here for you. If the conformal coating has fluorescence properties, what type of light source is used for inspection for coverage after cure? Will a black light work?
Yes, it will. That's what you would do. Exactly.
All right. Going over to you, Barry. Let's see. Are these light curable conformal coatings compatible for use on multi-layer PCBs with micro VS?
Absolutely. One of the most difficult parts of any conformal coating process is actually getting the coating on the sides of the board. I've had cases where I've had over 16 layers of backplane circuitry all tied into each other. Most customers will only coat top and bottom, depending on the type of side edge rail conveyor that you're using. So it is kind of important to try to get some of that coating on the actual edges of the board itself to prevent delamination of the individual laminate layers.
All right, over to you, Ginny. Question here is, can I reuse the mask after it is peeled off?
Unfortunately, no. With the light curable materials, it's a one-time use.
All right. And back to you, Chris. Are urethane, acrylate-based UVA cure, or dual cure conformal coatings allowed to be used for coating LED PCBs? And I can repeat that if you need it.
No, I think the question may be that once it's exposed to the LED, it can develop heat and the conformal coating might yellow. But there are many applications where these secondary moisture cure materials are being used to coat those boards and coat well. But you do have to naturally test the specific materials, because it does depend again on how thick of a coating you're putting on, what the temperatures are you're seeing, but they do have that capability to perform in that application. It would be application dependent and something you want to think about.
All right, question here for you, Barry. Is there a requirement, hold on, it just jumped. Okay, is there a requirement for the used solder paste, fluxes, and conditioning of the PCB?
Well, Lori, that varies tremendously from one manufacturer to another. There are literally dozens of different solder masks, as well as dozens of different solder pastes that are in use today. So getting all of these chemistries to work together is really the responsibility of the assembler to make sure that they're going to be compatible with each other. The no-lead solder fluxes require a much higher or hotter solder profile, and that additional heat and higher temperatures can cause a lot of things to happen on the board. The solder mask can leach certain agents such as glycol components, which are basically required for dendritic growth and tin whisker formations. So it's kind of an open-ended question, and you really need to do your homework and make sure that the fluxes and solder masks and alloys that you're using are going to be compatible and work in harmony with each other.
Okay, I have one here for you, Ginny. If using both peelable masks and conformal coatings on the same board, what is the order in which they should be dispensed and cured? Can they be cured at the same time under the same light source?
Lori, thanks for the question. In this particular case, yes, peelable masks and conformal coatings can be used on the same board. You would put down the mask first and cure it, and then apply the conformal coating. The reason I say that is with the conformal coating sprayed, you have the chance of the spray of the conformal coating actually moving the mask, if it's not cured, to an area that is beyond the keep out zone. So it really is preferable to put the mask on, dispense it, cure it, and then go into your conformal coating to spray it and then cure it after that. It is the same, exact same light source. You just, it's best if you are doing areas where the conformal coating could possibly move the masking into an area outside of the keep out zone, that I would not recommend curing them both and at the same time.
All right. I'm going to go over to Ginny. How do you determine the required UV power, intensity, and cure cycle to make sure the material is cured?
All right. One of the things that you're going to start with is the technical data sheet that is developed by the manufacturer of the light curable materials. Dymax, we provide all of this information to you on our product data sheets. And this is determined during the development phase. The chemists, as Chris indicated, that the formulation is developed to a specific light source. So the intensity and the minimum light intensity and wavelength are designed right into the formulation. As far as the cure cycle, We will, in our application engineering group, we will determine at what point the material is tack-free and has reached the hardness that it no longer changes. And that is the point that we determine the cure cycle. And all of that information is referenced on the product data sheet as a reference for you.
Okay, then over to you, Barry. If using a lead-free solder alloy, what can the residue be and other resulting issues by the higher temperature profiles required for lead-free solder alloys?
Good question, Lori, and this goes back to my previous question. There can be a lot because of these types of alloys require much hotter temperatures to reflow. There are some challenges involved trying to get all of those flux species, the actual acids and ionic species to volatilize or evaporate as part of the reflow process. This can be a very difficult and tricky thing to do when you have mixed technology assemblies, because in a reflow profile, the larger, bulkier components will actually rob that heat away from flat, unencumbered areas, thus leaving a extensive residue behind, which will typically need to be cleaned off. It is the recommendation of the IPC to clean boards that are going to be destined for conformal coating for some of these reasons.
All right, I've got a question here from Ginny. What's the easy way to avoid or improve tacky surface?
I'm assuming that they're talking about the light-curable masking. If not, I apologize. I'm going to make the assumption that it's light-curable masking. To improve and avoid the tacky surface would be that you follow the proper guidelines for curing on the product data sheet with the proper wavelength and intensity that is defined on the product data sheet. If it's applicable to the conformal coatings, again, you would follow the guidelines for curing for the UV portion and wait for the prescribed period of time for the moisture cure.
All right, thank you. And it looks like we have time for just one last question. I'm going to shoot this one over to you, Chris. Can 100% green materials like secondary moisture cure material mentioned be coated onto themselves, for example, to build up material or to rework a board?
Yeah, Lori, thanks. That is actually a good question, because with secondary moisture cure materials, it's best to recoat or rework the boards as soon as you can. After the secondary moisture cure takes place, there is a polarity change in the surface of the on the surface of the material, so on the surface of the board. So it can be more difficult to bond to. So you do have to test that, but in general, if you have to apply additional material or rework the board, the earlier you do that before full moisture cure is better. You can also apply other conformal coatings to those surface areas, and they will bond to the secondary moisture cure conformal coating. So that's another alternative that can be used.
All right, well, thank you so much. And before we do wrap up, I wanted to give each of our panel members an opportunity to leave us with any final or closing comments. And Chris, I'll go ahead and start with you.
Sure, I think they were some very good questions, and we certainly appreciate the opportunity to cover what we have here. And we do think there are these efficiencies that people can take advantage of, and if there is something that you'd like discussed that we didn't cover, please let us know.
All right, thanks, Chris. Barry?
Well, Lori, first of all, I'd like to thank the staff at Dymax for letting me participate in today's webinar. I think we've proven very, without a shadow of a doubt, that these UV curable conformal coatings as well as temporary maskants can reduce costs it can save an awful lot of time and aggravation in the conformal coating process, and definitely are more energy efficient than running 70-foot long thermal tunnels and having to extract large amounts of cubic volume of your heat and air conditioning in the appropriate months. So I think without a shadow of a doubt we've shown that here today.
All right, thank you. And how about you, Ginny?
I'd just like to concur with what Chris and Barry have said about the light curable materials, and I want to thank everybody that attended the webinar today, and I encourage you to check out our website at www.dymax.com and pick up the phone and contact our application engineers to talk about how we actually can help you save operating costs and improve your bottom line. Thank you.
All right, well, thank you. And folks, thank you all for joining, and trust that you found today to be of value. Thank you, Chris, Ginny, Barry, our presenters today, and of course our co-sponsor and co-host Dymax. Again, thanks for joining. This is Lori Dearman saying, hope we see you on the next one. Have a good one. Bye for now.